Hello, hello, my dear friends. Is my audio and the video is clear? Is my audio and the video is clear? Anyone who is in the live, just say me that the audio and the video is clear. The one who is in the live, just say me whether the audio and the video is clear. Good evening, Hari Prasad. Good evening. Can anyone say me whether the video and the audio is clear? Good evening, Nitya. Good evening, Akshara. Good evening, Joshita. Good evening, Subhana. Good evening, everyone. Once you say me whether the video and audio is clear, yes, clear, right. And if it is a clear, then we'll start the class. Right. Now today we are going to start the very important lecture of our JEE mains as well as a NEET. This is very important. Why? Because these basics will play very crucial role in the application part of our chemistry. See, this redox reaction, whatever we are going to study, this will play a very important role in our application part of our chemistry. Why in the application part? How it will play very crucial role, you know. Let's suppose if we start finding the oxidation number that we are going to study in this redox reaction chapter. If we know how to find the oxidation number, then how to identify the oxidation number of the given species, and if you are in that stage to find the oxidation number, whether the given compound is an acid, whether the given compound is base, or whether the given compound is amphoteric. Now based on this type of the concepts will be clear for us. Clear? Now we'll learn what are the basics that we are going to start in our redox reaction. Based on that we'll do the plenty of the questions. Okay, my dear friends, if you are not able to understand, just you ask me in the comment section, and whenever I was giving the questions, try to say me the answers. Okay, right? Now first we are going to start with the redox reactions. Now in this redox reaction, first redox reactions. Now in this redox reaction, what we are going to study? Now in this redox reaction, the main thing we are going to study about the oxidation and the reduction. Now what is the meaning of the oxidation and what is the meaning of the reduction? Here, can anyone who are in the live, can anyone say me what is the meaning of oxidation and what is the meaning of reduction? Can anyone say me what is the meaning of oxidation and what is the meaning of reduction? Can anyone say me what is the meaning of oxidation and what is the meaning of reduction? Hi, Shwetank, hi. Now, here in this redox reaction, the mainly we are going to study about the oxidation, and the next one is the reduction. Now the basic introduction of the oxidation and the reduction I will give you. What is the basic introduction of the oxidation and the reduction? Means here, if any Loss of electron, gain of electron. Right. Now, the loss of electron is known as the oxidation. Now, the gain of electron is known as the reduction. Done. Now, the loss of electron is known as the oxidation and the gain of electron is known as the reduction. Now, we will see here next point. Second point. Now, adding of oxygen, oxidation and loss of oxygen, reduction. Good, Nitya, good. Now, if you add any electronegative atom, that is oxygen. Now, addition of oxygen and here the removal of oxygen. Done. Now, the third point here, removal of what? Removal of hydrogen. Now, the third point here, addition of or adding of hydrogen. Next point here, this is very key point. Now, increasing in oxidation state, here decreasing in oxidation state, right? Increasing in the oxidation state is oxidation, decreasing in oxidation state we call it as a reduction. These are the some key points you have to remember. Clear? Now, this will play very crucial role. Now, sir, what is the meaning of oxidation and what is the meaning of the reduction? We got to know. Then, how to identify the oxidation state? Now, before going to start the oxidation states of the any elements, now what is the meaning of the oxidation state? Oxidation state. Now, what is the meaning of the oxidation state? Means real or assumed charge present on atom, real or assumed charge present on atom in substance or in the substance. That substance means molecule or atom or ions. This is known as the oxidation state. Now, next one, before going to calculate our rules to calculate the oxidation state, we have to know the how to identify the oxidation number of the given atom or given species or given molecule. Now, this is the one key point and the very trick and the very key and important trick I will say you. Whatever may be the atom or element they may give, how easily to identify the oxidation number of the given elements means, here first we'll write the second period elements. What are the second period elements we are having? This is lithium, beryllium, right, boron, carbon, nitrogen, oxygen and the fluorine, and this is a neon, right? Now, here it is a helium, right? Now, we know gain of electron and the loss of electron will be happened by the valency electrons. Okay, that you have to be very careful with this one. Now, in the chemical bonding we have studied. What we have studied in the chemical bonding? Here, any compound to form a bond, its valency electrons only will be participated in the bond formation. Either may be the loss of electron, either may be in the form of gain of electron, or either may be in the form of sharing of electron. That we know, we have studied very well in the chemical bonding. How the bonds are forming? Clear? Only the valency electrons will be formation in the bond. Here also, first is the second period elements. This is the which one? Alkali metals. Alkali metals valency electrons are 1, right? Now, beryllium valency electrons are 2, right? Now, boron valency electrons are 3. Now carbon valency electrons are 4, so its group number is also 4. Now nitrogen valency electrons are 5. Oxygen valency electrons are 6, so its group number is 6. Now halogens group number valency electrons are 7, so its group number is 7. Next one is a noble gas. Now here, if any element, if they have given, how to identify whether its oxidation number you don't know, then how to easily identify its oxidation number means, see, every elements want to attain the noble gas electronic configuration to fill its octet, right. Now to fill the octet, now here lithium to reach the helium electronic configuration means helium atomic number is 2. Now lithium atomic number is 3. Now this lithium to reach its helium electronic configuration, now it should lose 1 electron, right. Now the same lithium to reach the neon electronic configuration, it should gain the how many electrons? 7 electrons. So loss of 1 electron is easy or gain of 7 electrons is easy. Loss of 1 electron is easy, right? That's the reason this entire alkali metals will readily lose 1 electron. That's the reason this entire alkali metals oxidation number is +1, right. Now next, beryllium. When it comes to the alkaline earth metals, here beryllium to reach the helium electronic configuration or to fill the noble gas electronic configuration or duplet electronic configuration, it should readily lose the 2 electron, so that it will reach to the helium electronic configuration. Now here to reach the neon electronic configuration, it should gain the 6 electron. Gaining of 6 is easy or loss of 2 is easy? Loss of 2 is easy, right? That's the reason its oxidation number will be entire this alkaline earth metals oxidation number will be +2. Now next comes to the boron. Now when it comes to the boron family, loss of 3 is easy instead of gain of 5. So here it is a +3, right? Now carbon it is in the intermediate. Either it can lose the 4 electrons, either it can gain the 4 electrons. Now nitrogen family, it can readily lose the 5 electrons and it can readily gain the 3 electrons. If it is readily gain the 3 electrons, it will reach to the neon electronic configuration. If it is readily lost the 5 electrons, it will reach to the helium electronic configuration, right. Now oxygen it can show the +-2 and +6 because it can readily lose the 6 electron, it can readily gain the 2 electrons. Now halogen, fluorine will show the -1 oxidation state only. Now what are the stable oxidation state of these metals if they are, these elements if they ask? Now nitrogen it is -3, oxygen it is -2, now fluorine it is -1, but oxygen it is having some variable oxidation state. Now how the oxygen it is having the variable oxidation state? Now how the nitrogen is showing -3 oxidation state as well as the +5 oxidation state? Now fluorine will never and ever will show the +1 oxidation state or +7 oxidation state, only it will show only the -1 oxidation state. Can anyone say me why the fluorine will only show the -1 oxidation state? Why not +7 oxidation state? Can anyone say me why the fluorine is showing only -1 oxidation state? Why not the +7 oxidation state? Why the fluorine is showing only -1 oxidation state? Why not the +7? Why not the +7? Can anyone? Why not the +7? Yes, the fluorine being the more electronegative, it will readily gain the 1 electron to reach the noble gas electronic configuration, and it will not lose the 7 electrons. Good, Ari Prasad, good. Due to the high electronegative element. Good, good, Joshita, good. Due to the high electronegative element. Good, Akshara, good. Good, Subhana. Due to the more electronegativity. Fluorine being the more electronegativity, it will not readily lose the 7 electron. That's the reason it will readily gain the electrons, but it will never and ever will lose the electron. Right? Now, oxygen most stable oxidation state is -2, but only in the case of when it is attached with the more electronegative element, then only it will show the +1 oxidation state or +2 oxidation state of the oxygen, and the remaining in the all the cases except in the peroxide, superoxide, clear, in that case the remaining all the cases oxygen will show the -2 oxidation state. Now what are the, now I hope it is clear how to remember the oxidation numbers of the given elements. Right? Now group 1 metals oxidation number is +1, group 2 metals oxidation number is +2. Next, group 3 elements oxidation number is +3. Next, group 4 elements oxidation number is +4 and the -4. Next, group 5, this is +5 and the -3. Nitrogen will show the -3, -3, -2, -1, 0, +1, +2, +3, +4 and the +5 oxidation states, because nitrogen being the forming bond with the oxygen or in the oxides and the acids, it will show the variable oxidation states. Right? Oxygen major oxidation number, many of the cases we will take it as a -2. Right? In the rest other cases it is having -1, +1. How it is having, I will say you. Right? In the fluorine halogens it will show -1 as well as +1, but fluorine will show only -1 oxidation number. Right? I hope it is clear for you. Acha. Okay, Amma Tanmay. Okay, fine. Okay. Right. Okay, fine. Now we'll see the rules to calculate the oxidation state. Rules to calculate oxidation state. Rules to calculate the oxidation state. Now, what are the rules to calculate the oxidation state means? Now, first rule, oxidation state of an atom in its elementary state is 0. This is very important. Many of the students, they will make it the mistake here itself. What if any atom, if it is present in its elementary state or stable state, its oxidation number is 0. Example, if oxygen it is there, O2 it is present in the nature as a O2 gas. So when the O2 molecule, if they have given, if they ask what is the oxidation number of the O2, oxidation number of the O2 will be 0. And N2 gas, what is the oxidation number of the N2 gas? If they ask, N2 is present in its elemental form as a gas. Now its oxidation number is 0. If they ask what is the oxidation number of the H2 gas, H2 is stable in its elemental, H2 hydrogen is stable in the H2 gas. Why? One hydrogen atom it is having 1 electron and another hydrogen atom it is having 1 electron. Mutually when they are sharing the electrons, now it will form the H2 gas. When they are forming the H2 gas, they are reached to the noble gas. When they have reached to the noble gas, they became the stable. That's the reason hydrogen will be stable in the H2. When the hydrogen is stable in the H2, its oxidation number will be 0. Right? Hello my dear team player. Your name I cannot see. Something with the different name you came. Next, Cl2 gas, its oxidation number is 0. Right? Next, F2 gas, its oxidation number is 0, right? Next, Se8 solid, its oxidation number is 0 because sulfur is stable in Se8. Next, P4 phosphorus is stable in P4, right? Next, carbon, many of the students they will get confused in the carbon. Carbon, if they have given graphite only, carbon is stable in graphite and its oxidation number is 0, right? Next, if suppose Br2 liquid, if they have given, oxidation number is 0 because bromine will be exist in the nature as liquid, not the gas. My dear friends, you have to be very careful. Bromine gas they have given, its oxidation number is not 0. Bromine liquid if they have given, its oxidation number is 0. Next, I2 solid if they have given, oxidation number is 0. I2 iodine will be exist in the nature as solid, right? Now these are the some elements whose oxidation number is 0. You have to be very careful with this one. No. Carbon only graphite. Carbon only graphite is stable, so its oxidation number is 0. Not about diamond, not about the fullerenes. If suppose the diamond they have given, its oxidation number is not 0. No, diamond stable oxidation state, my dear friend. You have to be very careful with this one. This statement whatever I was given, that you have to read, my dear friend. Okay, elemental state or stable state. Now carbon stable state is graphite, it's carbon, its oxidation number is 0, right? Next one, the next very key point you have to remember, that is oxidation state of fluorine. Oxidation state of fluorine is equal to -1. Oxidation state of the fluorine is -1. Why? Because it is a more electronegative element. It will readily take the electron and its oxidation number always it will be shown it as a -1, right? Next very key point that you have to remember, that is third one, that hydrogen. Clear? Now the hydrogen oxidation number, my dear friend, whatever may be the doubt you are having, that it is maybe the clear for you or not, I don't know, right? My dear friend, then the stable state, the carbon oxidation number. Okay, my dear friend, you are clear with your concept, right? You can go. If you are still, if you want to study, you can study. Now the hydrogen oxidation state, is +1 and -1. Hydrogen, it can show the oxidation state +1 and the -1. When it will show the +1 oxidation state and when it will show the -1 oxidation state. Now if the hydrogen attached with which one? More electronegative elements. If the hydrogen attached with the more electronegative elements, its oxidation number is +1, right? Now if hydrogen attached with metal, if the hydrogen is attached with the metals, its electronegative, if the hydrogen is attached with the metals, its oxidation state will be the -1, right? Its oxidation state will be the -1. Its oxidation state will be the -1. Okay, now next one, oxygen oxidation state. Now the next one, fourth one. Now the oxidation states of oxygen. Oxidation state of the oxygen. Generally the oxidation state of the oxygen is -2, right? In peroxide, if they have given the peroxide, oxidation state of oxygen is -1, right? Next one, superoxide, oxidation state of oxygen is -half, right? Next one, now in the ozone O3 or ozonides, its oxidation number of the oxygen is -1/3, right? Now most of the cases oxygen oxidation number is how much? -2, right? Then only in the case of when it is attached with the O2F2, when it is attached to the O2F2, now what is the oxidation number of the oxygen and why it is showing the other than -2? Can anyone say me? Can anyone say me? Okay. Now what is the oxidation number in the KO3? Now what is the oxidation number of the oxygen here? Can anyone say me what is the oxidation number of the oxygen here? No. Oxygen, I'm asking oxygen. And why? And why? And why? Now what is the oxygen oxidation number? No, what is the oxygen oxidation number? Not the -1. It is +1. See here, the oxygen in the peroxide means H2O2. No. Peroxide means H2O2, right? Superoxide and the peroxide and the ozonide, this is when the oxygen, when it is forming the compounds, this is the ozonide. In the ozonide and the superoxide, peroxide means H2O2. Now hydrogen oxidation number when it is attached with the more electronegative elements, this is 2 + 1 + 2x is equal to 0. Now +2 and the x, if you take it to the left hand side, it will become 2x is equal to -2, x is equal to -1. When the oxygen, when it is forming when its nature of bonding changes, its oxidation number also will be changes. Is it clear? Oxygen can show the peroxide, oxygen can show the superoxide, oxygen can show the ozonides. Clear? Right? Oxygen can show the peroxide, oxygen can show the superoxide, oxygen can show the ozonides. So depending upon its nature of bonding, its oxidation numbers will be changed. Clear? Based on the oxidation numbers also we can say how many bonds it can form. Based on the oxidation numbers also we can say how many bonds it can form. Now you can see in the O2F2. Now if you take the oxygen, we know which is the more electronegative, oxygen or fluorine. Can anyone say me among the oxygen and the fluorine which is more electronegative? Which is the more electronegative? Based on the nature of bondings also we can say or based on the oxidation numbers also we can say how many or what is the oxidation number of the atom. If the oxidation number of the atom changes, then we can say how many bonds it can form. See, oxygen and the fluorine. Electronegativity of fluorine is greater than oxygen. Electronegativity of fluorine is greater than oxygen, right? If the electronegativity of fluorine is greater than oxygen, you can see this is 2x. You want to find the oxidation number, then fluorine always it will show the -1 oxidation state, that it will be equal to 0. Then 2x minus 2 is equal to 0. X is equal to, if you send the 2 to the left hand side, it will become plus 2 and it will be the x. X is equal to plus 1. X is equal to plus 1. Then if the x is equal to plus 1, then the oxidation number of the oxygen is plus 2. See, you can see here, when the oxygen it is forming the bonds with the different nature, its oxidation numbers will be shown. Oxidation number of the oxygen generally it is a -2. In the peroxide it is -1. In the superoxide it is -1/2. Now in the ozonide it is -1/3. Then when it is formed the bond with the more electronegative atom than the oxygen, then its oxidation number is +1. Then if suppose if they have given oxidation number of the OF2, if suppose when it has formed the bond with the R compound as a OF2, can anyone say me what is the oxidation number of the oxygen here? Can anyone say me what is the oxidation number of the oxygen here? What is the oxidation number of the oxygen here? What is the oxidation number of the oxygen here? What is the oxidation number of the oxygen here? Yes, good. It is a +2 oxidation state. Right. It is a +2 oxidation state because the fluorine being the more electronegative. What? Fluorine being the more electronegative. Right. Good. Now, next. Now I hope it is clear how to identify the oxidation numbers and what are the oxidation numbers of the alkali metals, alkaline earth metals, and the group 3 and the group 4, group 5, group 6 and the group 7, because every element or atom want to attain its noble gas electronic configuration, right? Due to that it is showing the variable oxidation states. But the very interesting thing you have to remember for the oxygen as well as for the hydrogen. Hydrogen, when it is attached with the more electronegative element, it shows the +1 oxidation state. When the hydrogen, when it is attached with the metals, it will show the -1 oxidation state. See why it is showing the -1 oxidation state, why it will show the +1 oxidation state. Now we'll see. If you take it as a HCl, right? Now when compare with the hydrogen, chlorine is more electronegative. Chlorine, if it is more electronegative, now chlorine what it will do? It will pull the bond pair of electron towards itself. Up to 845 I will run. Okay, up to 845. Now chlorine being the more electronegative, it will pull the electrons, right? When it is pulling the electron towards itself, it will get the what? Partially negative charge. It will get the partially positive charge. Now this partially positive charge indicates that it is loss of electron. Now when the more electronegative atom is attached to the hydrogen, now it is having the +1 oxidation state because loss of electron. Now you see, when it is formed the bond with the metal, in the case of metal hydride, if you take it as a lithium hydride, if you take the lithium hydride, we know metal will readily lose the electron because this lithium will comes under the group 1. Group 1 metals will readily lose the electron. It will not readily gain the electron. When it is readily lost the electron, when that another should be gained the electron, right? Metal, if it is losing one electron, then the other species should be gain the electron. That is known as the redox reaction. Loss of electron and the gain of electron should be happen in the reaction or in the species. If one atom is losing the electron, other should be gain the electron. Then if the metal is losing the electron, then hydrogen should be gain the electron, right? That's the reason hydrogen is having the -1 oxidation state. You have to be very careful with this one. Hydrogens, when it is attached with the metals, it will show the -1 oxidation state. When it is attached with the electronegative elements, then it will show the +1 oxidation state. Clear? I hope it is clear for everyone. Then oxygen general oxidation number is -2. Then in the super peroxides -1, and the superoxides -1/2, and the ozonide, in the ozonide, not the ozone, ozonide, in the ozonide it is -1/3, right? And in the O2F2 it is +1, and in the OF2 it is +2, right? I hope it is clear for everyone. I hope it is clear for everyone. Or still you are having any confusion? Is it clear? Is it clear to everyone? Is it clear to everyone, or still you are having any confusion? Yes, clear, right? Now we'll see next very important statement or important concept to calculate the oxidation numbers, that you have to, what you have to remember means, let's suppose electronegativity of A is more than, if the electronegativity of A is more than electronegativity of B, right? If the electronegativity of A is more than electronegativity of B, let's suppose this A and B has formed the compound. A and B has formed the one compound. Now what is the oxidation number of the A and what is the oxidation number of the B? What is the oxidation number of the A and what is the oxidation number of the B? If this concept, I will explain very clearly. If this concept, if it is clear for you, in the upcoming whatever may be the concepts of the chemistry you are going to study, it will be very clear for you, and within the fraction of seconds you can say. Now among the A and B, let A is more electronegative than the B. Suppose electronegativity of A is more than the B. Then what is the oxidation number of the A here? What is the oxidation number of the B here? Now what is the oxidation number of the A here? What is the oxidation number of the B here? Next, what is the oxidation number of the A and B in the second one, right? And what is the oxidation number of A and B in the 3? What is the oxidation number of the A and what is the oxidation number of the A in second compound? What is the oxidation number of the A in third compound? A is -1, B is +1. Good. Now, see what I said. A is more electronegative than the B, right? What is the meaning of electronegativity? What is the meaning of electronegativity? Electronegativity means tendency to pull the bond pair of electron towards itself. Tendency to pull the bond pair of electron towards itself means from the B, electrons are coming to the A. When the electrons are coming to the A, B means losing the electrons. If the B is losing the electrons, it will get the +1. Now A is gaining the electron, right? It will get the -1, right? Here only one bond it is there. Only in the one bond it is there. If the A is having the only one bond, it is having the -1 oxidation state, B is having the +1 oxidation state. Now in the second one, can anyone say me in the second one? In the second one, what is the oxidation number of the A and what is the oxidation number of the B? What is the oxidation number of the A and what is the oxidation number of the B? In the second. In the second it is -2 and here it is a +2. Why it is a -2? Because here from 1 sigma bond electrons are moving towards the more electronegative atoms. Now 2 bonds are losing, here the B is losing its 2 electrons, right? Because how the double bond will be formed? Now the A 2 electrons and the B 2 electrons. A 2 electrons and the B is 2 electrons, right? When they are forming the bond. Now the more electronegative atom will pull this 2 electron towards itself, right? When it is pulling its 2 electron towards itself, now what is the oxidation number of the A? A is -2 and the B is +2, right? You can see here it is forming the 3 electrons, right? Now when it is having the 3 electrons, now it will pull the 3 electron towards itself. When it is pulling the 3 electrons towards itself, now what it will happen? Now it is a -3 and here it is a +3, right? Now it is a -3 and here it is a +3. I hope it is clear for everyone. This is clear. I hope it is clear for everyone. Yes, done. Now I will give some compounds. That compounds oxidation number you have to find out. That compounds oxidation number you have to find out. Here in the first one, K2, not K2, no, H3PO4. What is the phosphorus oxidation state? And H2S sulfur oxidation state. One I will explain, remaining you have to do, right? Next, second one, and the third one, MnO4 minus, right? Next one, fourth one, H3O plus oxygen oxidation number, here the Mn. Now we'll see here phosphorus oxidation number, right? Now how many atoms we are having, that you have to write 3 + 1, because hydrogen is attached with the more electronegative of the phosphorus, right? And it is X, because actually it will be attached with the oxygen. Now X plus 4 into -2, then equal to 0. Then it is a +3 and here it is a -8. +3 and the -8, it will give you the -5. So X minus 5 is equal to 0. If you send the 5 to the left hand side, then what it will happen? X is equal to +5. Now the phosphorus oxidation number is +5. Now in the H2S, here the sulfur oxidation number we have to need. Now 2 + 1 plus X. Now X is equal to +2, right? If you send it to the left hand side, it will become -2. Sulfur, it is -2. Now what is the oxidation number of the Mn here? What is the oxidation number of the oxygen in the 3 and 4? Now you say me, what is the oxidation number of Mn and what is the oxidation number of the Mn and what is the oxidation number of the oxygen in the 3 and 4? In the 3 and 4, what is the oxidation number of the Mn, and in the 4, what is the oxidation number of the oxygen? Good, good, good. Now the third one, good, Joshida, good. Now X plus 4 minus 2 is equal to charge, we have to multiply, that is -1, right? X minus 8 is equal to -1. x, if you send it to the left hand side, x is equal to plus 7. X is equal to plus 7. Right. Now, here in the H3O plus, yes, good. Here the 3 plus 1 plus x is equal to plus 1. Now, that is x plus 3 is equal to plus 1, right? If you send it to the left hand side, x is equal to minus 2. Oxygen oxidation number is minus 2. Oxygen oxidation number is minus 2. Right? Next. Fifth. Now, next one. What is the oxidation number of nitrogen in N2? And in the 6, sulfur oxidation number. Now try to say me fastly, Amma. 7 in the NH3. Right? Now, here. Now say me fastly. What are the oxidation numbers of the given species? 8 CO3 minus 2, 9 NH4 plus, 10 OH minus, oxygen. Next, 11 C2O4 minus 2, carbon. Next one, here 12 C6 H12 O6, carbon. Right? Next. Now very fastly you have to say me. Now very fast you have to say me the answer. Now nitrogen, it is 3. Superoxide formula is KO2, ma. Okay, you want the compound of superoxide. Superoxide means KO2. That you will get to know more clearly when we start the S block elements. S block elements, when we start, there we will get to know. Okay, now what is the oxidation number in 13? What is the oxidation number of KO2? 14, what is the oxidation number of H2O2? And 15, what is the oxidation number of KO3? Okay, and 16, what is the oxidation number of O2? And 17, what is the oxidation number of H2O? All the oxidation numbers of the oxygens. All the oxidation number of the oxygens. Carbon. In the 8th one, carbon. 8th one, carbon. Nitrogen, it is present in its elemental form. Its oxidation number is 0. Now in the SO3, here it is plus 6, sulfur trioxide, 3 minus 2, that it will give you the plus 6. Now in the ammonia, nitrogen oxidation number is minus 3. Now in this carbonate ion, now the carbon oxidation number is how much? X 3 minus 2 is equal to minus 2. That if you send X is equal to plus 4. Carbon oxidation number is plus 4. Ninth, in the 9th, what is the 9th? Ammonium ion, it is a minus 3. Ammonium ion, it is a minus 3. 10th, oxygen oxidation number is minus 2. Right. Next, 11th. 10th, good. 10th, it is a minus 2. 11th. 11th, what is the oxidation number of the 11th? 11th plus 6. Carbon maximum to maximum it can show only +4. How come +6? This is 2x plus 4 minus 2 is equal to -2. 8. Here the carbon -8, if you send it to the left hand side, it will become 2x is equal to +6. X is equal to +3. This oxalate ion oxidation number of the carbon is +3, not the +4, not the +6. My dear friends, you have to be very careful with this one. It is only the +6. It is only the +3. Carbon maximum to maximum it can show only the +6 oxidation state. No. Here it is a +3. Next, here the carbon oxidation number is. Here the carbon oxidation number is. What is the oxidation number of? Yes. Now here the carbon oxidation number, here it is 0, right? Carbon oxidation number is 0. Here the carbon oxidation number is 0. Done? No. Now we'll go with the superoxide, peroxide, ozonide and O2 and H2O. Now you see me. Now that is plus of or minus of. Charge is also very important. It is a plus of or minus of. It is a plus of or minus of. It is a plus of or minus of. It is minus of. Here the potassium it is a +1 plus 2x is equal to 0. Now if you send the 1 to the left hand side, x is equal to minus of, right? Now in the superoxide, oxygen oxidation number is minus of. Minus of, it is not the plus of. Next, this is a peroxide. This is a peroxide. Charge is very important. Next, in the peroxide, H2O2. H2O2. What is the oxidation number of oxygen in 14? That is -1. 2x 2 minus 1 is equal to 0. Right? If you take the minus 2 to the left hand side, it will become the plus 2. It is, oh sorry, plus 1, plus 1. Hydrogen is plus 1. If you send it to the left hand side, it will become minus 2. Minus 2 by minus 2, it will become minus 1. So in the peroxide oxygen oxidation number is minus 1. Right. 15, ozonide. 15, it is a ozonide. Ah, 15, it is a minus 1 by 3. It is plus 1 plus 3x is equal to 0. Right? If you send it to the left hand side, x is equal to minus 1 by 3. In the ozonide, oxygen oxidation number is minus 1 by 3. Oxygen oxidation number is minus 1 by 3. Now O2, it is in the elemental form, its oxidation number is 0. O2, it is in its elemental form, its oxidation number is 0. 17, H2O, its oxidation number is minus 2. H2O, its oxidation number is minus 2. Next one. Next, some other compounds, if suppose if they have given, then how to identify? Next, some important oxidation numbers that you have to remember. That one is some exceptional oxidation numbers that we are going to see. This will play a very crucial role. Many of the students, they will get confused here. If suppose they have given H2SO5, this is the one Carus acid. Now what is the oxidation number of the sulfur here? And second one, H2S2O8, what is the oxidation number of the sulfur here? And third one, CrO5, what is the oxidation number of the chromium here? In the 1, what is the oxidation number of the sulfur? And in the 2, what is the oxidation number of the sulfur? In the 3, what is the oxidation number of the chromium? Now see me. What are the oxidation number of the sulfur and what is the oxidation number of the sulfur in the 2 and what is the oxidation number of the Now, yes, my dear friends, who are saying the oxidation number of the first one is the plus 8. Okay, listen. My dear friends, you are saying the oxidation number of the H2SO5 is a plus 8. It is, you are saying it as a plus 8. But my dear friends, can anyone say me valency electrons of the, my dear friends, whatever the answers you are saying, those are wrong. Now listen. Now the central atom here, it is a sulfur. If the central atom, if it is a sulfur, then sulfur valency electrons are how many? Sulfur valency electrons are 6. If sulfur, if it is lost its 6 electrons, it will reach to the neon electronic configuration. Okay, when it is reached to the neon electronic configuration, after reaching to the neon electronic configurations also, it is losing the 2 electrons you are saying. Means here the sulfur is losing the 8 electrons, means what, where it will reach? It will reach to the oxygen electronic configuration you are saying. But every element or atom want to attain the noble gas electronic configuration. One, it is attain to the noble gas electronic configuration, it will not readily lose its electron. It will not readily lose its electron, right? Then how come the sulfur will show the plus 8 oxidation state? Sulfur maximum valency electrons are only 6. then you are getting the oxidation number is plus 8. This plus indicates that loss of electron. Then you are saying it as a loss of electrons are 8. How it is possible? Sulfur can lose only the 6. But the oxidation number which you have said for the Carus acid H2SO5, it is not the plus 8. It is not the plus 8. It is a plus 6 oxidation state. Now, how it is having the plus 6 oxidation state means by the its oxy acid structure you have to find out. Now you see, sulfur maximum valencies are how many? How many? That 6, right? 1, 2, 3, 4, 5 and the 6. Right? Here how many hydrogens we are having? 2 hydrogens we are having. So 5 oxygens, 1 double bond O. Here it is a 1 OH. Right? Now here it is a 1 oxy acid peroxy structure. Right? Now how many it has happened? H2SO5, right? 1 oxygen, 2 oxygen, 3 oxygen, 4 oxygen. And the leftover 2 electrons will form the double bond here. Right? Now you see, here the sulfur is less electronegative. Oxygen is more electronegative, right? Now here the oxygen will pull the 2 electrons. Now sulfur got 2 deficiency. Here 1 oxygen is pulling the 1 electron. So 3 deficiency. Here the sulfur is pulling here the oxygen is pulling 1 electron. So 4 deficiency. And here oxygen it is pulling the 2 electrons. Total 6 electrons of the sulfur is dragging by the which one? Oxygen. So that's the reason its oxidation number is plus 6, not the plus 8. My dear friends, you have to be very careful with this one. Here when you calculate the oxidation number, you will get it as a plus 8. But H2SO5, its oxidation number is not the plus 8, it is plus 6. I hope it is clear for everyone. Next one is a H2SO8. Now this H2SO8, if you calculate, you will get it as a 2 plus 1 plus 2x plus 8 minus 2 is equal to 0. Then you will get it as a 2 plus 2x minus 16 is equal to 0. Then it will get it as a 14. Then x is equal to plus 7 you will get. But sulfur maximum valency electrons are only 6. Then how come it will show the plus 7 oxidation state? So here then you have to draw its oxy acid structure. What does it mean? Only one thing you have to remember, my dear friends. For the sulfur, more than plus 6 oxidation state, if you got, then you have to think that it has one peroxy linkage, right? It is having one peroxy linkage. Then H2S2O8. Now H2S2O8 structure will be, now sulfur, here how many oxygens we are having? 8, right? Now sulfur valency electrons are 6, right? Another sulfur valency electrons are 6. Done. Now here how many oxygens we are having? 8. Then one double bond O, here one double bond O, right? One double bond O, one double bond O, right? Oxygen valency is clear because oxygen valency electrons are how many? Total oxygen valency, oxygen it is having the 6 valency. Now 2 has participated in the bond and remaining 2 are the lone pairs, right? Here also 2 lone pairs, here also 2 lone pairs. Oxygen's octet has been completed. Remaining how many unbonded oxygens we are having? 4. So each oxygen will form the single bond with the sulfur and with the hydrogen. Here also one single bond with the oxygen and with the hydrogen, right? Remaining we are having only the 2 electrons and remaining unbonded oxygens are 2. So the each oxygen will form the single bond in this manner. Now this is a one peroxy linkage that it is present in the H2S2O8. Now in this H2S2O8, now you can see the sulfur oxidation number. Here the sulfur it is losing the electrons. Now oxygen it is a more electronegative, it is dragging the 2 electrons. Here the sulfur oxygen more electronegative, it will dragging the 2 electrons. Here the sulfur more oxygen more electronegative, it is dragging the 1 electron. Here the sulfur and oxygen is more electronegative, it is dragging the 1 electron. See the central oxygen, here it is a +6 oxidation state, here it is a +6 oxidation, because here the 2 electron dragging by oxygen, here the 1 electron dragging by oxygen, here the 2, here the 1. So in the H2S2O8 its oxidation numbers are +6 and the +6. Right? Now next one, CrOF5. CrOF5, if you calculate, you will get the valence, its oxidation number is +10. But in the CrO5, chromium maximum valency electrons are 6. How? Chromium atomic number is 24. Then if you write its electronic configuration, that is 4s1 3d5. Maximum to maximum, chromium can lose only the 6 electron. But here the +10 indicating that chromium is loss of 10 electrons. It is saying that chromium has lost the 10 electron, but it is not at all possible. Then chromium is present in the different manner, that it is present in the butterfly structure like this. CrO. These all are terminals only. This is terminal only. This is terminal. This is terminal. This is terminal. Now this is terminal. This is terminal. This is terminal. Terminal. These are oxy acids, okay, I will explain. Let me finish this one. Let me finish this one, and I will explain how the oxy acids can be drawn in the H2S2O8, how the oxy acids can be drawn in H2SO5. Let me finish this one. Now in the CrO5, now it will form the butterfly structure in this manner. Oxygen maximum to the maximum valency is 2. Oxygen can form only the 2 bonds. Right. In this manner, chromium will form the structure in the butterfly structure in this manner. Now you can see chromium and oxygen. Oxygen is more electronegative, it is dragging the 2 electrons. Now here the chromium and oxygen, it is dragging the 1 electron. Here the chromium and oxygen dragging the 1 electron. Here oxygen one dragging the 1 electron. Now here the oxygen one dragging the 1. You may get a doubt, sir, here this oxygen and this oxygen and this oxygen, what about this bond? This bond, here oxygen electronegativity is 3.5. Here the oxygen electronegativity is 3.5. Both the electronegativities are same. If both the electronegativities are same, what happened to this bond? There is no any dragging of electrons, because electronegativity difference is only not there. So here the loss of 6 electron, chromium it is having the +6 oxidation state. Now, sir, how to draw the oxy acids and how to identify the oxidation numbers of sulfurs in the oxy acids? Now I will say you one trick. If you remember this trick, whatever may be the compound they may ask, directly you can predict the oxidation number of that atom. First, I will say you oxy acids of phosphorus. This is a trick to identify the oxy acids of the phosphorus first. Like H3PO4 they have given. H3PO4 they have given. H3PO4 if they have given, phosphorus oxidation number if I ask, it is a how much? Here it is a P, now here it is a X, now here it is a 4 minus 2 is equal to 0. Now here the 3, X minus 8 is equal to 0. That it will give you the X is equal to +5. This is a +5. So this is on the basis of doing formula. With the structure, how can I explain? With the structure, how can I explain means, now you can see. For the oxy acids of the phosphorus, what are the key points you have to remember? Phosphorus should have one double bond O and one OH, it should be mandatory. One is oxy acids of the phosphorus if they have given. For that oxy acids, one double bond O, one OH should be mandatory. Then next point, this is H3PO4 only I will draw. H3PO4, one double bond O and one OH, right? Next, here how many oxygens are balanced? 2. How many hydrogens balanced? 1. Remaining hydrogens unbalanced are 2 and remaining oxygens unbalanced are 2, right? Then here phosphorus maximum to maximum valency electrons are only 5, right? Here phosphorus can form only 5 bonds. You can see here one OH. Oxygen will form only the double bonds, right? Here one oxygen and it will form the bond with hydrogen. Now here will the one oxygen and it will form the bond with the hydrogen. Now this is the structure of H3PO4. Done. Now all the atoms octet has been completed. Now it is stable. Now you can see here, if I calculate the phosphorus oxidation state, now phosphorus, it is losing the 5 electrons when it is attached with the oxygen, so its oxidation number is +5. Its oxidation number is +5. I hope it is clear. I hope it is clear. Now in the sulfur oxy acids, if you want to draw oxy acids of sulfur, then what are the mandatory to show the oxy acid? Any compound to show the mandatory oxy acid, sulfur, it should have one double bond O and one OH. And one very key point note is that hydrogen directly will not attach with sulfur, right? This is the one key point you have to remember. Hydrogen directly will not attach to the sulfur, right? Here if I want to draw the structure of H2SO4, now here in the H2SO4, one hydrogen balanced, two oxygen balanced. Now unbalanced are one hydrogen and the two oxygens, right? Sulfur valency electrons are 6, right? Now here one oxygen, it will form the one double bond like this. Next one oxygen, one hydrogen, one single bond, one hydrogen. Now this is the structure of H2SO4. Now you can see oxidation number. Here the 6 oxygens are pulling the electron towards itself and it will show the +6 oxidation state. I hope it is clear for everyone. Or still you are having any confusion? My dear friends, still you are having any confusion or is it clear? Is it clear or are you having any confusion? Clear, right? Now should I give some elements or some compounds? Now I will give you some compounds. Now my dear friends, try to say me those oxidation numbers in the comment section. Okay, in the comment section try to say me the oxidation numbers of those compounds. Okay, first one here in the H4P2O8, second one H2S2O7, sulfur oxidation number, here the P2 oxidation number. Next one, third one H3PO2, phosphorus oxidation number. Next one, fourth one H3PO5, phosphorus oxidation number. Next 5 C2H2, carbon oxidation number. Next 6 CCl4, carbon oxidation number. Now these 3 elements oxidation number, try to find out the 6 elements oxidation number, try to find out and say me in the comment section. I will see who will say the first in the comment section. Now that comment will be pinned first. Okay my dear friends, if you are having any concerns you can ask me, if not we can leave. Now I will stop the class here. Now I will stop the lecture here. Now we'll see you tomorrow with the what is the meaning of oxidation and the reduction, that, and after that how to balance the oxidation of reaction and the reduction of reaction in the acidic medium and the basic medium. Clear? Now my dear friends, anyone are having any concerns or if anyone want to ask any doubts, if anyone want to ask doubts or anything, or should I end the lecture? Good night my dear friends, good night. Okay, right. We'll see you tomorrow. Bye. We'll see you tomorrow. Good night, everyone. Bye.